Good morning, good afternoon, welcome. I'm very pleased to be joined by Ivor van Dartel, who is the co-founder of VÆRIDION. Welcome, Ivor. Thanks for joining.
Thank you for the invitation.
So, Ivor, you're going to be speaking at the Sustainable Aviation Futures Congress, which is fast approaching. It's the end of this week, indeed, 7th to the 9th of June in Amsterdam. Clearly, VÆRIDION, it may be a bit unknown. It's a new, exciting sustainable aviation concept or aircraft you're developing. So do you want to give us maybe a little bit of your background? You're obviously previously many years in Airbus. So yeah, give us a short introduction to yourself and then maybe unpick the actual basic concept of VÆRIDION.
All right, so I've studied aerospace engineering in Delft, which is not far from Amsterdam. Then after my studies joined Airbus, where I worked in several roles, among them on the e-aircraft systems program back in the day. Obviously, the company developing large commercial aircraft, we thought that there might be an opportunity in a smaller aircraft category. And being here in the Munich area, which is very friendly towards deep tech startups, we quit our jobs and founded VÆRIDION with the aim of developing a microliner, which means it's a small airplane meant for commercial air transport, completely battery electric.
Excellent. And the actual powertrain, it's a turboprop or it's a propeller.
So it's indeed a propeller which is driven by electric motors. We are developing something we call the single propeller multi-engine. So we have a fully safe and redundant multi-engine architecture on a single shaft. The fact that electric motors are so much lighter and more compact allows you to do things mechanically that previously was not so easy to do with gas turbines.
Yeah, and the number of passengers you can carry.
So we are in the CS23 level 3 category, which limits the number of seats up to 9. Mm-hmm. And we want to stay below 5.7 tons maximum takeoff mass, which would allow us to do single pilot operations as well.
Right. And that sort of form factor, you see that being, developing as a sort of decentralized fleet, as it were, or?
Well, indeed, the economics of the aircraft will be such that you can start to fly between smaller regional airports, which are greatly underserved today, or it was not economical to serve them. So that with, let's say, lower demand destinations, you will fill up a 9-seater quite all right, but maybe not a 100-seater. Mm-hmm. And there's a great potential for this because in Europe and in the United States, we have thousands of these regional airports just sitting there. And actually, there's a lot of people who are traveling by car on these routes because they have no other alternative today. So apart from, let's say, replacing existing short-haul flights, we can also start offering services that are simply not existing today in the air.
Yeah, and the range of the aircraft and sort of flights would typically be.
Well, indeed, battery technology offers some limitations nowadays. So we believe that with today's battery technology, we could offer flights to up to 500 kilometers. If it's a full aircraft under instrument flight rules, it's maybe rather 400 kilometers. But there are many destinations, at least in Europe, that fall in that category. And especially in those countries such as Germany or the Scandinavian countries or France, Italy, Spain, there are the many networks you can build using the existing airports.
Yeah. And what sort of speed would the plane do?
So we would fly rather slow to conserve energy. Typically, we would fly around maybe 130 knots. Mm-hmm. Or let's say 250 kilometers or slightly below. We could fly faster, but it would reduce our range. Similar, if you have an electric car, if you go faster, you reduce your range. Yeah, it's basically the same thing.
Yeah, yeah. And whereabouts are you in terms of the building the demo, or what's your current status in terms of development?
So we are still pretty much in the early stages of conceptual design and technology development. So we have finished our complete performance baseline of the aircraft, and we have developed the 2 key enabling technologies, which are being patented and for which hardware tests have commenced. And our next step will be to evolve the organization from a technology team into an aircraft development team, for which we are also actually fundraising.
Yeah, excellent. And around the IP and some of the innovation and technologies, I guess it's around some of the batteries as well, and trying to get the lightest batteries.
Indeed, there are actually three factors to success for any electric aircraft. On the one hand is, of course, getting the best technology in terms of chemistry, but then indeed to get from a best possible cell to pack ratio, which means you should make the battery packaging as light as possible or as well integrated with the primary structure as possible. And then, of course, it needs to be an aircraft that's aerodynamically efficient, more than average, as well as lightweight. And these three factors then enable you to do a meaningful range with a, of course, smaller airplane. But this is just the first step.
Yeah. And where are your batteries? In the main fuselage, or?
So we, in fact, integrate the batteries in the wing. As is known since a long time, putting heavy parts in the wing helps to alleviate the bending moment or the shear force. The wing is carrying the entire weight. It's a lift force upwards, but if you put weight in the wings, like today, fuel is in the wings, engines are hanging there, it alleviates the bending moment at the root. And it also keeps the batteries away from the fuselage. So there's a number of failure modes you have to look at. And actually, it makes a lot of sense to put them in the wing.
Yeah, excellent. And in terms of the market, that sort of market sizing and the economics of that route, what are some of your thoughts there around the economics of the market, shall we say?
So we have a rather parametric view on the topic. First of all, we have developed a parametric cost model, which of course over time we adopt, which means how much will it cost to run the airplane. We believe we will be able to offer a trip cost of less than 300 euros one way at a profit for a 400-kilometer trip. So this is slightly more expensive than your average economy class seat, but it's below the price point of a business class seat on short haul. So with those figures, we believe we can, of course, enter the existing GA market or maybe the light business aviation market, those operating the turboprops, as well as offer an alternative to those regional operators who fly below 40-seat turboprops, who either need to go to a bigger airplane or a smaller one because there's no replacement in production today.
Yeah.
This is the rather conservative business case, inserting the microliner in existing frameworks. There is also another scenario which is now being researched and published about by many noteworthy companies such as McKinsey, Roland Berger, NASA. It's the regional air mobility scenario, in which a lot of people who are not flying today, but traveling by either car mostly, will switch to a air connection, which is delivered from their nearest small regional airfield or airport. And this travel demand is therefore real. The question is whether these people will then start to switch to the new offering, for which we believe normal business travelers will be the early adopters, because for a slightly higher price, you buy time. So it's not as expensive as private aviation is nowadays, but it's certainly within reach of the normal business travelers.
Yeah, and also I guess private aviation is also a market in terms of the higher end private aviation.
Definitely, even though private aviation, I have learned recently, is quite a diverse industry. In fact, you have, of course, the higher upper end of very wealthy individuals. But you have also a segment which is, let's say, being discovered by many normal business travelers. So we also believe that if the price point of private aviation could be lowered, then a lot of, let's say, normal business travelers, they don't have to be the CEO of a listed company, will start to choose the option because it's just very convenient. And in our case, would be completely emission free.
Yeah, sounds fascinating. Sounds perfect. Indeed, and certainly imagine that being a market that would certainly grow, especially the obviously avoiding traffic and point to point. So yeah, fascinating stuff. We look forward to hearing more and seeing VÆRIDION develop over the coming years, and look forward indeed to hearing your engagement and speech and talking at the Congress later this week. So Ivor, many thanks for talking to us. Great concept, and we wish you success in building the craft and seeing VÆRIDION fly at some point in the future.
Thank you, Nadim. See you in Amsterdam.
See you in Amsterdam. Take care. Bye-bye.